Okay, so we are talking about the properties related to set union, intersection and complement. So, these two properties is called De Morgan's law. We will prove these two properties. So, first let us prove the first one. So, this is now this is x set and this is y set. Now, we have to show x equal to y. So, for that we know the approach. So, first of all we have to show x is a subset of y and then we have to show y is a subset of x, and if both we can prove, then we can say x equal to y. Now, to show this x is a subset of y, we have to take an element a from x and then at the end we have to show dot 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 dot, we have to show this a belongs to. So, we have to show this imply a belongs to y. This we have to show, then only we can say x is a subset of y. So, how to show this? So, x is basically a complement. Now, if x is in the complement, so that means a does not belongs to this. If a belongs to the complement, so that means a does not belongs to that set, that is the definition of the complement. So, if a does not belongs to this set means this is union. So, a does not belongs to a and a does not belongs to b. So, this implies if a does not belongs to their union, that means a does not belongs to one of them, otherwise a belongs to the union. So, a does not belongs to this and a does not belongs to b. Otherwise, if a belongs to a, capital A, then a must belongs to a union b, which is not correct. Or if a belongs to b, then a belongs to a union b, which is not correct. So, that means this is true. Now, this means what? This means a belongs to a complement and a belongs to b complement. So, now this is the intersection. So, this means a belongs to a complement intersection b complement, which is the y. So, that means any element of this set is an element of this set. So, that means this is a subset of this. So, for one way we have proved that. Now, the other way around, we have to take an element from this set and we have to show that is also an element of this set. Then we can say this is a subset of this. So, this both will tell us that these two sets are equal. So, let us try that. So, we take an element from this set. So, we take B belongs to A complement union B complement. So, now we have to show this belongs to this. So, let us try that. So, this belongs to the intersection means this belongs to A complement and B belongs to B complement. And now, it belongs to complement B means it does not belongs to A and B does not belongs to B. Okay. Now, if it does not belongs to both A and B, then it does not belongs to the union, because union is the or collection of element which are either in A or in B. So, this implies B does not belongs to A union B set. So, this implies B belongs to their complement. That is it. So, B belongs to this set. So, that means this is a subset of this, and earlier we have proved this is a subset of this, hence these two sets are equal. So, this is the first law, and the second law is A intersection B complement is equal to A complement union of B complement. Okay. So, now again how to prove this? This is a property or the law. Now, how to prove this? Now, again same way, this is a x set and this is a y set. We have to show x equal to two sets are equal. So, we know the way, we have to show x is a subset of y and y is a subset of x, then we are done. So, for that what we need to take? We need to take an element from this A, then we have to show this is an element of this set. So, this means what? A must not belongs to A intersection B. If it is belongs to the complement, then A must not belongs to A intersection B. So, A intersection B A must not belongs to means, so when A either it not in A or not in B. So, that means A does not belongs to A or A does not belongs to B. If it is or not and, because this does not belongs to their intersection, that means it is not a common point of A intersection B, A B. So, if it is not a common point means either A not belongs to A small a or small a not belongs to B. So, that means A belongs to A complement or A belongs to B complement. So, this implies A belongs to A complement union B complement. So, this part is done. We have taken an element from this set, we have proved that that is an element of this set. So, this is a subset of this, and similarly we can take an element from this set and then we can show this is also an element for this set. That let us try that. So, this part is showing that, so whatever we have seen, this is showing that this is a subset of this. The first part is done. Now, what we have to show? We have to show that this is a subset of this set. Now, for that what this need to show? This is done and this is yet to show. Okay. So, now for that what we need to take? We need to take an element from this set. So, let us take an B belongs to A complement intersection B complement, sorry, this will be union, this set, this will be union. So, this in union of this. Now, if this is belongs to this, so that means B belongs to either A complement or B belongs to B complement. Now, if B belongs to A complement, this implies B does not belongs to A or B does not belongs to B. Now, if B either not in A or not in B. So, this implies B does not belongs to their intersection. For intersection, B has to be in both the place. So, this implies B does not belongs to A intersection B, does not belongs to. So, this implies B belongs to A intersection B complement. So, that means, if we take an element of this set, we just prove that is an element of this set. So, that will give us the that is the proof. Okay. So, this is called De Morgan's law. Now, we will define two more operation on this set operation. The first one is the difference operation on of A and B, and it is denoted by A minus B. If we take two set A B, A minus B is basically set of all elements which are in A, but not in B. Okay. So, this is the element in A, but it must not be in B. Okay. So, this is the set of all elements which are in A, but not in B. So, this is called, this is the A union B, sorry, A difference B. Okay. So, this is basically we can say this is basically A intersection with the B complement. Now, we can have some properties on this. Say the first property is A minus B intersection C is basically A minus B union A minus C. Okay. If you take 3 sets A, B, C, then this is a result. So, how to prove this? Let us try to prove this. So, we have two sets x and y. We need to say similar way that x equal to y. So, we have to show. So, we take an element from this set x. So, this means what? This means A belongs to A, but A does not belongs to this. Okay. A belongs to A, but this. Now, this implies what? This implies A belongs to A, but and A does not belongs to their intersection means A does not belongs to B or either one of these. A does not belongs to C. So, that means A does not belongs to A and either one of these is true. So, we take A does not belong, A belong, this is always true. Now, with this we can take this A belongs to capital A and A does not belongs to B. This is one case, or A belongs to, this is always true, A belongs to A and sorry, this is A and A does not belongs to C. Now, this is giving us A belongs to A minus B, or this is giving us A belongs to A minus C. Now, this two will give us A belongs to A minus B intersection A minus C, sorry, union A minus C. So, that this is the set. So, that means, if we take an element from this set, we can easily show that this is an element of this set. So, that means, this is a subset of this. Now, in other way around, we can show if you take an element of this set, that will be an element of this set. So, that is telling us this is a subset of this. So, if we combine these two, we can get this result. Okay. Now, the second property is so second property for this is A minus B intersection C is basically A minus B intersection of A minus C. So, earlier one here this was union intersection, here we have union, and here we have intersection. So, how to prove this? Again by similar way, we take an element from here and that we have to show that is an element of this set. So, that means this is a subset of this, and again we take an element from here and we have to show this is a. So, let us try that. So, this is a x set, this is a y set. So, basically you have to show x is a subset of y and y is a subset of x, and these both will give us x equal to y. Now, to show this one, what we need to show? We need to take an element from x and we need to prove that this is an element of y. Then this will give us x is a subset of y. And to show this, what we need to show? We need to take an element from y and we need to show that that is an element of x. So, that means y is a subset of x, and combine these two will give us x equal to y. So, let us try that. Okay, so, let us take an element from this set. So, this set is A minus B union C. So, now we have to show that this is an element of this set also. So, let us try that. So, this means A belongs to A and A does not belongs to B union C. So, this implies A belongs to A, that is always true, and A does not belongs to B union C means A is not in B or not in C, because otherwise if A is either of this B or C, then A belongs to B or C. So, this means A does not belongs to B or and sorry not or. So, A does not belongs to B union C means E does not belongs to any one of this, otherwise A belongs to B union C. So, this and A does not belongs to C. You understand? Otherwise, if A belongs to small a belongs to B or C, any one of these, then small a belongs to B union C, but that is not. A does not belongs to this means this is true. Now, these two we can combine and we can have A belongs to A and A does not belongs to B and A belongs to A and A does not belongs to C. So, these two will give us this will give us does not belongs to sorry, this will give us A belongs to A minus B first one and A belongs to A minus C second one. So, A belongs to this means this implies A belongs to their intersection A minus B intersection of A minus C. Okay. So, that this is the set. So, if we take an element from this, that will be an element from that set. Now, we have to show the other way around. We take an element from this, we have to show this is an element of this. Let us just try that quickly. So, let us take an element from this set. Okay. Now, we need to show this is an element of this set. So, how to proceed? So, yeah. So, let us try that. So, this means a B belongs to. So, B is in this means B belongs to A intersection B and B belongs to this. So, this implies B belongs to. So, this first one means B belongs to A and B does not belongs to B. This is the first part and this is and similarly here also B belongs to A and B does not belongs to C. This is the second part. Now, in the both the cases B belongs to A, no doubt. So, B belongs to A, and so if you combine these ands, it will give us and B sorry, this B does not, this is B does not belong. So, B does not belongs to B and B does not belongs to C. So, B does not belongs to B and B does not belongs to C. So, if you combine these two, this will give us B does not belongs to B union C. So, this implies and B does not belongs to B, sorry, difference C, sorry, B union C. So, this implies B belongs to A minus B union C. This is the set. So, if you take an element from this set, we just prove that is also an element of this set. So, this is the way we can prove that. Okay, so, let us have another symmetric difference notation of two set A B. So, that is basically denoted by this symbol symmetric difference. This is a set notation, set operation between two sets. So, this is denoted by this. This is basically the element which are either belongs to A or belongs to B, but not the both. So, this is basically the A minus B union of B minus A. So, this is basically set of all elements which belongs either to A or to B, but not in both. Okay, so, this is also equal to A intersection B minus of A this. So, this is basically A set difference of B. Okay, so, this is the way we define this. Now, this is the another set operation. Now, we will define the notation of Venn diagram, and then we will see using the Venn diagram most of the operations are very easily to prove. Venn diagram. So, we can represent a set in a diagram way. So, suppose A is a set, say 1, 2, 3, 4, these are the elements. So, this is the pictorial way. So, this is 1, this is 2, this is 3, this is 4. This is called Venn diagram. So, this is a set. We are seeing this in a pictorial way. Now, if we have this notation, then how to define A union B? So, we have a set A, we have another set B. Now, A union B is, so this is the universe. So, A union B is this set. This set is basically A union B. Okay. Now, what is the A intersection B? So, if we have the intersection is basically this set common point. So, this dark one, this is basically A intersection B, and this whole set is, this set is basically A union B. Okay. Now, using Venn diagram, it is easy to see the complement. Suppose we have a set A and this is the universe. this is set A. Now, A complement is basically set of all elements belongs to here. These are the A complement. So, this is the universe, this is A. So, A complement is not in A. Okay. So, now this is the complement. Now, what is the difference? A minus B. So, we have a set, this is A, this is B. So, A minus B means this one. So, it is in A, but not in B. So, this set is basically A minus B. Okay. And similarly, this set is B minus A. So, this is the way we represent this representation is called Venn diagram representation. So, this is the this is one of the pictorial way we can represent a set. Okay. So, this way it will help us to see the proof, like if we want to see whether what is the A union B complement. Okay. Suppose this is the set A, this is the set B, this is universe. So, this is A, this is B. Now, what is A union B? A union B is this one. This is A union B set. Okay. So, all the elements over here. Now, its complement means this one. Okay. Now, that is nothing but A complement intersection B complement, because A complement is, what is A complement? A complement is this one, after outside A, B complement is this one. So, their intersection means basically this one. So, by seeing this Venn diagram, we can easily those proof will be little more easier. Now, subset means if we have two set A B, this is A set, this is a B set. Now, B is a subset of A. If every element of B is an element of A, and then A is a superset of B. Okay. And these are the element in A minus B. So, this is the way we view this set in a Venn diagram. Thank you.